Hello, my name is Marilyn Andrews. This is a research project with Liberty University, College Education, course 734. And the title of the project is Multimedia Learning and Cognitive Load. Multimedia design and cognitive load. The role of multimedia design in traditional curriculum enhances the overall learning experience from a technological and cognitive perspective. The cognitive load theory is an instructional theory that seeks to optimize instructional content and optimize learning opportunities based on human brain architecture. Mayer's cognitive theory of multimedia learning is based on three principles, including the information processing channels for visual and pictorial information, channels with limited processing channels, and active learning requirements for cognitive processes. When selecting learning materials within an online environment, each of the cognitive learning channels need to be considered to ensure optimal student learning results from the learning experience. Multimedia modes and cognitive load research. The multimedia and redundancy principles particularly deal with multimedia input modes and their influence on learning content knowledge. The multimedia, there are several areas uncovered within the research study, including the relationship between cognitive load, satisfaction, anxiety, student achievement, student identity, and student perception of AR-based vocabulary content when displayed using different presentation modes. Within a research study, the overall goal of the research was to find ways to integrate the cognitive theory of learning into augmented reality or AR technology in instructional, virtual, and in-person settings for student learning. The overall results of this research showed that while participants were not familiar with targeted language, the use of the AR or augmented technology in application of the modality principle were useful. One participant stated, "I found the visuals useful and very interesting, especially when they were presented with text and narration." None of the students reported experiencing anxiety during the study. Students also held mixed views as it relates to the modality and redundancy principle and the redundancy of the content. One student stated, "I think seeing the text is half of the learning process. I believe text should also be accompanied by narrations." Cognitive load theory. The cognitive load theory is defined as the total load placed on the working memory by the instructional information. According to research, the cognitive load theory suggests that the higher the learner's prior knowledge, i.e., the more expert the learner, the lower the intrinsic cognitive load or complexity experienced. The intrinsic load can be defined as how a complex learning task or problem can be specific to a given learner. Research also finds that the intrinsic mode determines whether a learner has enough working memory to process cognitive activities or if cognitive overload has already occurred. To determine the strength of one's intrinsic load, the measurement of interactions between the individual and the learning elements need to be taken. The germane cognitive load is defined as the mental effort necessary for constructing the schema during learning. The learner's germane load increases when the instructional design creates the opportunity for information to be transferred from working memory to the long-term memory. As a result, the learner is able to retain information into their long-term memory given that the number of distractions have been reduced. Instructional processes and curriculum design should focus on reducing extraneous load and maximizing germane load without exceeding the learner's cognitive capacity. The modality principle. The modality principle is the separating of visual and audio content for processing purposes. When presenting the modality principle, presenting some information in visual mode and other information in auditory mode can expand effective working memory capacity and so reduce the effects of an excessive cognitive load. There are psychological advantages to presenting information through two channels. When processing information using the modality principle, individuals are able to split the content into two separate cognitive channels. The audio is in one channel and the visual is in another. This is done to prevent cognitive load. Another effect of the modality principle is the use of audio text rather than placing words on a screen. Again, this prevents cognitive load and the learner can focus on one means of content rather than several at one time. Multimedia lessons that present on-screen text presents a challenge for the human mind. Furthermore, people have separate information processing channels for visuals, pictorial processing, and for auditorial verbal processing. There are still elements of the modality principle that needs further research. Those areas include dialogue between characters, narration, audio narration benefits, and when to place words on screen with concurrent graphics. The redundancy principle. The redundancy principle states that repetitive or redundant information does not enhance the learning experience, but rather takes from it. The text of Clark and Mayer of 2016 defines redundant text as printed on screen and narrated text. When an image is already narrated, the redundant principle states irrelevance to adding additional narration to the screen. As an example, a presentation that contains narration, animation, and concurrent on-screen text can cause cognitive overload. Cognitive load in multimedia learning environments. Multimedia designs which appeal to different sensing and processing channels are defined as those that present words, narration or text, and pictures, illustration, photography, animation, and video together. As technology continues to advance in education, integration into the learning environment develops significantly. It is ultimately the instructional designer's responsibility to ensure the learning materials cater to the unique learning needs of their students. Instructional designers, or IDs, should account for the way information is processed by learners when designing visual displays. Learners learn new information through two processors, verbal or pictorial. The complexity of learning takes place when learners are asked to process both pictures and verbal content into their processing channels. Cognitive load theorists state that the design and presentation of instructional material should reflect the significant limitations of the human processing system. Previous work on the integration of verbal and visual information when reading traditional text has shown that this integration can be challenging, and there are indications that making in multimedia reading environments poses even greater processing demands on the reader or learner. Digital literacy. Because classrooms are increasingly diverse, it is challenging for educators to provide learning opportunities that are inclusive for all students. Since students now live in a world with endless online opportunities to indulge in audio, visual, and imagery, the goal is to transform passive internet viewers into active and reflective evaluators. Examples of effective technology integration include providing students with the option to view TV shows and websites through an analytical and reflective lens. Teachers might also create opportunities for students to collaborate or act out scenes of a movie as a means of comprehension. Digital literacy and cognitive load. Although students are presented with information online, further steps have to be taken for them to understand the information. Digital literacy skills require both cognitive and technical skills to develop a learner's ability to locate, use, and communicate information. Digital literacy requires both cognitive and technical skills to develop a learner's ability to once again locate, use, and communicate information. Social skills are at the core of digital literacy. In fact, research shows that critical thinking, problem solving, and social intelligence are the new skills required of learners online. Teaching learners to manage cognitive capacity and cognitive flexibility creates opportunity to develop mastery in their own domain knowledge to become competent global citizens. In conclusion, cognitive load theory seeks to correlate the learner's ability to retain information in their working memory to ultimately achieve digital literacy and overall learner achievement. Learners' ability to transfer knowledge technically, socially, and cognitively across multiple disciplines is a necessary skill to achieve digital literacy. Cognitive load theory seeks to correlate the learner's ability to retain information in their working memory to achieve digital literacy and learner achievement. The multimedia principles, redundancy, and modality address the need for instructional designers to carefully select materials that enhance the learner's ability to retain information. The research provided highlights the complexity of selecting the appropriate instructional materials to feed into the cognitive load of the learner. And here are my references, and thank you for watching my research project.